Right, so this is part 2 of the actual, as described on the front title this time, part 2 of trying to identify how we solve these complicated trig problems and just what we need to look out for. So, what I've got up here is actually quite a complicated example, and I think quite a good example to show of how we are mixing R formulas and double angle formulas. Well, sorry, R method and double angle formula. I can see that I've got an x over 2 here, okay, but straight away I should think, well, that's an x. So if that's an x, double angle formula means x is double this one, so I should be able to use my double angle formula for that and get that in terms of, again, maybe a cos x equals this time, because remember cos 2x. So cos 2x is the same as 1 minus 2 sine squared x. Yeah? Remember that from our previous problem, in the previous video? Well, here, because I know that this 2 sine x is going to give me, in terms of, 2 sine x cos x, so I won't split that one. But if I split this one, I can recognize that this is actually some variation of cos x, but with our double or half angles. So cos x equals 1 minus 2 sine squared x over 2. All right, now it looks very, very similar. And if I manipulate this and move that 2 sine squared x over 2 over, I get 2 sine squared x over 2 is the same as 1 minus cos x. Here I've got just sine squared x over 2, not 2 sine, so if I divide everything by 2, sine squared x over 2 is the same as a half minus a half cos x. Now I can plug this into my original problem. So sine squared x over 2 is actually a half minus a half cos x equals 2 sine x. Put sines and coses on the same side, so I get 2 sine x plus a half cos x equals a half between 0, x and 360 degrees. And look at what we've got this time. So I've got theta is the same, I've got a mix of cos and sine, and I've got constants next to my sine and cos. So let's see, we need to use the R method, don't we? So R sine x plus alpha is the addition formula we need, the R method. And this is going to be the same as 2 sine x plus a half cos x, which equals a half. Yeah? So if I'm comparing the coefficients of this, when I expand this out, I get R sine x cos alpha plus R cos x sine alpha is the same as 2 sine x plus a half cos x. So comparing coefficients, I've got R cos alpha, so I've got sine x here, I've got sine x here, so this thing must equal 2, and R sine alpha must be the same, I've got cos x here, I've got cos x here, must equal a half then. So if I put them over each other, R sine alpha over R cos alpha is the same as tan alpha, which is the same as a half divided by 2, so that's 1 over 4. So therefore my alpha equals tan to the minus 1, make sure your calculator is in degrees, tan to the minus 1 of 1 over 4 is 14.04 degrees to 4 SF, because remember we need to get our final answers in terms of 3 significant figures, so we'll work to 4. So that's a 0. And then we need to find out R, and I could do the whole triangle method like I did before, but I can just show that R squared actually equals a half squared plus 2 squared with experience. I don't need to keep writing out my triangle, I can just see that R then equals 1 over 4 plus 4, which means R equals 5 over 4. So I can rewrite my whole new equation, what I started with, which was this thing here, I've rewrote that in terms of my R method, and I can say that I have 5 over 4 sine x plus my alpha 14.04 degrees equals, where are we, equals a half. And then divide both sides by 5 over 4, get sine x plus 14.04, because remember I can't have things next to my sines when I work this out. So I get this equal to, that would be 4 over 10, which is 2 over 5, because a half divided by 5 over 4 flips over 2 over 5. And then I would just solve as normal using cost. Now if I look at this problem here, again, it's the same scenario. You can start seeing that this is a mixture of double angles, isn't it? Here I've got an x and here I've got half of that theta there. So if I combine, or if I turn this x over 2 in terms of tan x, or this tan x rather in terms of x over 2, I can say that this thing here is 3 times tan x, which is the same as 3 times 2 tan x over 2 divided by 1 minus tan squared x over 2, from our tan 2x is the same as 2 tan x over 1 minus tan squared x. Yeah? Okay, because remember I have to get the thetas the same in order to start working with this. Right, so if I'm working from here and sub that back in, I have 2 tan x over 2 plus 3 times this thing, if I put that in, is 6 tan x over 2 divided by 1 minus tan squared x over 2, which equals 0. Times both sides by 1 minus tan squared x over 2, and I get 2 tan x over 2 minus 2 tan cubed x over 2 plus 6 tan x over 2 equals 0. Simplify this up again. I've got 2 and a 6 tan x over 2, so this is 8 tan x over 2 minus 2 tan cubed x over 2 equals 0. Take out a factor of 2 tan x over 2, and I get 4 minus tan squared x over 2 equals 0. So that means that either 2 tan x over 2 equals 0, so 2 tan x over 2 equals 0, or tan squared x over 2 equals 4. So again, I can't have things next to my tan, so I divide both sides by 2, so I get tan x over 2 equals 0. That's number 1 to work with. And here I've got tan squared x over 2 equals 4, so I need to square it both sides, so I get tan x over 2 equals 2, so that's my second solution to work with, and tan x over 2 equals minus 2. That's my third thing to work with. Okay, and then cast as normal, change range, do it for the individual things, and you'll get your answers. Last one. Sine 2x plus sine 4x plus sine 6x. Could use double angles maybe, but probably wouldn't get anywhere. The whole thing equals 0. I've got mixtures of sine plus sines. This must be the factor formula, mustn't it? So let's put that in terms of our factor formula. Actually, let's not be too hasty with this sine 2x. Let's put these two in terms of our factor formula and see what comes out. Maybe we'll get a factor of sine 2x, I don't know. This is what I mean. We're experimenting with our methods, we're looking at it and we're kind of thinking, that kind of looks like that. Okay, so this is the same as 2 sine p plus q over 2 cos p minus q over 2, where p is 4x in q is 6x, so therefore I have 2 sine 4x plus 6x over 2 cos 4x minus 6x over 2. So this gives me 2 sine, well that's 10x over 2, so 5x cos 4x minus 2 minus 6x is minus 2x divided by 2 is minus x, but remember cos of the minus anything is still that thing here. So I get 2 sine 5x cos x, which is this part. I still got this plus sine 2x here equals 0. Right, so sine 2x is the same as 2 sine x cos x, isn't it? So let's do that. 2 sine 5x cos x plus 2 sine x cos x equals 0. Take out a factor of cos x then and 2, so 2 cos x sine 5x plus sine x equals 0. Ah, look here. Okay. This is in the form of my factor formula again, isn't it? This is in the form of the factor formula. So let's do that again. Let's try that again and see what we get. If we get 2 cos x, we'll do this part in terms of our factor formula. Just remember the whole point is we're trying to eliminate terms. So this thing is 2 sine 5x plus x divided by 2, because remember it's p plus q over 2, will give me sine 3x times cos 5x minus x is my, so 5x minus x is 4x divided by 2 is cos 2x. So actually I have 2 cos x times 2 sine 3x cos 2x equals 0. If I expand that out, I have 4 cos x sine 3x cos 2x equals 0. Therefore, I can safely say that 4 cos x equals 0, sine 3x equals 0, and cos 2x equals 0. So I've got 1, 2, 3 solutions, as before. So you see, there are a number of methods we could use for this. It really is a case of, let's try this, let's try that. You know, we kind of know what we're looking for. If I see something immediately obvious, like this next question, if I see something like this is so obvious that I have to use the R method. I've got a coefficient, I've got cos and I've got sine, and it equals some constant. I know I've got to use the R method for that. But the other things which aren't so obvious, which is this kind of thing, I know I've got to use a factor formula, but you know, maybe I can manipulate things in a certain way. Maybe I can look for factors to come out. Okay? It really is experience all these things. So practice, practice, practice. Use your C3 textbooks to practice these problems, the mixed exercise, and you'll get there.